So the third colligative property that we're going to talk about is called freezing point depression. Okay, and this says that the freezing point of a solution is always lower than the freezing point of the pure solvent. Okay, this is why we put salt on the roads in the wintertime, because water is going to freeze when it hits 0 degrees Celsius or 32 Fahrenheit. But if we spread salt on the roads, it actually lowers the freezing point, so the roads won't freeze until like 5 below or something. The problem with salt on the roads, of course, is that it attacks your car, and it's not too good for your car. So a lot of times they'll just use sand instead, which is not a colligative property. That's just about the friction that it adds. So this is a graph just kind of showing you. If you look at the blue line, I think it is, you can see that as time goes by, okay, the temperature decreases. Okay, so in this line here, it goes down, does this little dip, that's called supercooling, it's not important, and then it levels off until all of the liquid has turned into solid, and then it would cool off again. So in this state right here, I have just liquid. Here, my liquid is turning into a solid, and here I just have solid. So if I look across, I can find the freezing point of my pure solvent. Okay? If I do this with a solution, though, it actually goes a little bit lower, and it never quite levels off, and then it goes down again. And so now your freezing point is going to be a little bit lower. Okay? Why does it never level off there? Well, as it freezes, some of the solute turns into a liquid, so the solution that you have left becomes more concentrated. So now its freezing point goes down even a little bit more, and as solute freezes, it becomes more concentrated, so the freezing point gets a little lower, and as it freezes, more solute comes out and becomes more concentrated, and it gets a little lower. So it never quite levels off here. We usually call the freezing point of the solution right here, though, where it starts to go down. So why does this happen? Well, let's look at just plain pure solvent. So, for instance, water or something, okay? As these molecules try to come in and out of the solid state into the liquid state, they can move easily in and out of that because there's nothing in the way. Okay, but over here, when it's trying to move from the solid out into the liquid state, you notice that you have all of these ions that basically are just getting in the way. They're making it hard for these solvent molecules to come back in and form sort of a really structured crystal. So it's not a very scientific reason, but basically the ions get in the way. That's all you need to know about why freezing point lowers. So we can calculate how much the freezing point changes. Okay, this is the freezing point change, not the actual freezing point, but the change. This is a constant. Okay, remember it's based on the solvent. All right, so it'll always be given to you. Okay, this here is molality. All right, molality is little m, moles of solute per kilogram of solvent. And of course that's your I, your Van Hoff factor. This is your Kf for water. You don't have to memorize it. I'll always give you Ks. Okay. You'll notice hopefully that this equation looks almost exactly like the one for delta Tb. Okay, it's just a Kf instead of a Kb. So why don't we practice a problem? Okay, what's the freezing point of a solution prepared by dissolving 25.9 grams ammonium sulfate in 750 milliliters of water? So probably the first thing we're going to want to do, right, is figure out what molality is. So the first thing we'll do is we'll change 25.9 grams of ammonium sulfate. All right, make sure you get your formula right. So we change grams to moles. Because I'm nice, I'll tell you it weighs 132.16. Okay, so that's going to give you 0.196 moles of ammonium sulfate. So then the molality is the moles, okay, moles, divided by kilograms of solvent. Okay, well, we've got 750 milliliters, so that's 750 grams, or 0.75 kilograms. So we'll put that here. Okay, And if we do that out, we get a molality of 0.261 molal. So now we'll go ahead and plug it into our formula for freezing point. So Kf is 1.86, molality is 0.261, and the I. So what's the I going to be for ammonium sulfate? Looks like we'll get 2 ammoniums and a sulfate, so I is 3. Okay, so this equals 1.46 degrees Celsius. Now again, that is not the answer. That's not the freezing point, that's the change in freezing point. That's the amount that it has decreased. So you have to know the normal freezing point of your substance. In this case it's water, so that's 0. So 0 minus 1.46 degrees Celsius is negative 1.46 degrees Celsius. And that would be the freezing point of that solution. So again, make sure you know what the colligative property is, why it exists, and be able to do a calculation. And that's it.